The solar system just had a visitor. Not just any visitor. Something that defies every expectation we've ever had about comets, asteroids, and the invisible threads that stitch the stars together. ESA's ExoMars Trace Gas Orbiter tracked it first in late 2025, a faint blur against the black canvas of space. We call it 3IATLAS, the third confirmed interstellar interloper, following in the footsteps of Oumuamua and Borisov. But this time, things are different. At first glance, you'd think it's just another comet. You know, the drill icy body. Some would approach, classic tail streaming behind like a cosmic kite. Except 3IATLAS didn't play by those rules. The moment ExoMars trained its instruments, scientists froze. There it was, a sharp, luminous core, almost like a jewel in space, with barely a trace of the diffuse tail we associate with sublimating ices. Minimal outgassing, minimal dust. Just presence. Dirt. Helena Vargas of ESA's Orbital Dynamics team shook her head when I spoke with her. "It's like a comet in disguise," she said. "We see the shape, the orbit, but it's behaving nothing like a comet should." And she wasn't exaggerating. Models that predicted plumes of vapor or dust failed entirely. Whatever 3IATLAS is, it refuses to fit the template. A sun, facing glow, and a flat path through the ecliptic. Now, here's the kicker. Most interstellar objects we catch have a steep approach vector, plunging in from some random inclination, arcing dramatically across the solar system before disappearing. Not 3IATLAS. This thing glided almost perfectly along the ecliptic plane, the very same plane where Earth, Mars, and Jupiter orbit. It's as if it knew the layout of our system. And the glow, oh, the glow. Most comets show a tail pointing away from the sun due to solar wind pressure, but 3IATLAS had a persistent sun, facing luminescence, an unnatural sheen that teased astronomers for weeks. Spectrometers tried to parse it, no obvious ice signatures, no detectable molecular emission lines typical of comets. Just light reflecting, glinting, and refusing to scatter the way we expect. It's almost as if the object has a reflective coating. Dr. Vargas whispered during a late night observation session. Something designed to catch sunlight, maybe to communicate, or maybe just survive. We chuckled nervously. Speculation is dangerous in astrophysics, but sometimes the universe forces your imagination to catch up. Mars and Jupiter flybys, gravity assists, or cosmic coincidence. The trajectory data is what really makes your jaw drop. 3IATLAS didn't just meander through our neighborhood. It skimmed Mars' orbital radius, then dipped near Jupiter's influence. Its path deflected in ways that look eerily like gravity assists, the kind spacecraft engineers carefully calculate when sending missions across the solar system. Coincidence? Perhaps. But imagine plotting thousands of random interstellar objects, each hurtling from the stars. How many would thread the solar system so elegantly, brushing planetary spheres of influence, and then exit almost perfectly along the ecliptic? Statistically, almost none. Dr. Kavita Rao, a theoretical physicist following the event, noted, "If this was a natural rock, it's the luckiest rock in human history. But if it's not, well, then it's something else entirely. Miles, scale size, minimal outgassing. Breaking the rules. We've measured its sizes several miles across, solid, compact, and dense. Now consider this: a body of this scale, approaching the sun, should outgas heavily. Heat should trigger sublimation, creating the majestic tails we see in comets. Yet 3IATLAS offers almost no detectable outgassing, barely a whisper of vapor, almost nothing to push against solar radiation. Think about that for a second. A multi-mile object, surviving perihelion without shedding material, without classic cometary behavior, and reflecting sunlight with that odd sun-facing glow. Every textbook would tell you this is impossible. And yet, there it is, moving through the inner solar system like a perfect interstellar phantom. Harise and Perseverance, debunking the viral cylinder. Of course, the internet exploded. Social media feeds lit up with images claiming Perseverance spotted a cylindrical craft near Mars. People were calling it an alien ship, a probe, a message. Let's set the record straight: no metallic cylinder exists in any official imagery. HiRISE images from the Mars Reconnaissance Orbiter captured nothing beyond pixel artifacts, cosmic ray streaks, and the occasional dust devil imprint. The viral clips, misinterpretation, exaggeration, digital noise amplified by imagination. But, and this is crucial, some subtle, fleeting albedo flashes did appear in multiple datasets, precisely where 3IATLAS crossed Mars' orbital plane. Brief, consistent, unexplained flashes. Not definitive evidence of anything, but enough to make a scientist sit up and think. There's something unusual here. From null hypothesis to bold speculation naturally, the scientific starting point is simples assume it's natural. A piece of interstellar debris, an unusually dense comet, a rote fragment from another system, the null hypothesis, as we call it. But as datasets poured in, optical, infrared, orbital dynamics, the anomalies kept stacking sun-facing glow without outgassing. Mile, scale density resisting sublimation. Near, perfect ecliptic traversal and gravity, assist, like trajectory. These observations begin to strain the limits of standard astrophysics. And when that happens, science allows speculation, not as conclusion, but as exploration. Enter the bold idea's technological relic, tumbling in silent orbit, reflecting sunlight at intervals. None, outgassing probe, possibly powered by internal mechanisms or light pressure. Beacon or message. A directed, intentional signal in visible or infrared bands. Each hypothesis generates testable predictions, and each in its own way stretches our imagination. 3IATLAS. Watching the interstellar phantom across the globe, observatories scrambled. Telescopes in Chile, Hawaii, and the Canary Islands trained on the sky, recording every flicker, every glint of this enigmatic interloper. Amateur astronomers reported streaks in backyard scopes, and radio arrays scanned for the faintest signals. The object didn't disappoint in curiosity. Its brightness oscillated in irregular intervals, not like a rotating comet shedding debris, not like a tumbling asteroid reflecting sunlight. It twinkled, almost like a signal. Spectrometers measured subtle shifts in reflected light, no organic emissions, no sublimated gases, just pure, sharp reflectivity. Dr. Michael Lang, an astrophysicist at the University of Arizona, leaned back in his chair one night, eyes glued to a plot of light intensity over time. "I've studied comets, asteroids, meteors," he said slowly. "And nothing behaves like this. It's a relic of some other physics, or something else entirely." The something else hung in the air like static electricity. Scientists are trained to doubt, to cling to the null hypothesis, but every dataset chipped away at conventional explanations. The cosmic highway ecliptic alignment and trajectory precision. 3IATLAS didn't just drift randomly. Its path was remarkably planar, almost like it was guided by invisible rails. Moving along the ecliptic, it approached Mars' orbital zone, but then Jupiter's gravity well, and finally traced a slingshot trajectory back toward interstellar space. Mathematical simulations confirmed it. The object's deviations fit a near, perfect energy, efficient path, the kind spacecraft engineers painstakingly calculate when designing gravity assist maneuvers. But this was not engineered by humans. There were no thrusters, no radio signals, nothing we could detect. Dr. Kavita Rao summarized the unease with a wry smile. "If I didn't know better, I'd say someone planned this trajectory. But if so, it's not ours." Even more puzzling, its acceleration. Slight, subtle, but measurable. And it didn't match the expected outgassing models. Radiation pressure alone couldn't account for the observed velocity shifts. Something unknown, natural or otherwise, was gently nudging it along its path. HiRISE, Perseverance, and the viral cylinder debunked. Meanwhile, the internet refused to wait for peer-reviewed papers. Within days, viral clips claimed Perseverance had spotted a cylinder-shaped object hovering near Mars. Headlines screamed, "Alien probe found. What really happened?" HiRISE images captured motion streaks caused by 3IATLAS as it passed behind Mars' LEM, combined with pixel saturation effects. The cylinder illusion arose from compression artifacts when images were cropped for social media. But a curious detail remained: the exact regions of 3IATLAS passage showed brief, repeating flashes in the reflected light. something subtle, fleeting, and otherwise unexplained. These flashes weren't strong enough to confirm anything, but their consistency hinted at a non-random property of the object. Scientists debated reflective surface irregularities, internal tumbling, rotational specular reflections, each plausible, none definitive. Miles across, and yet silent 3IATLAS measures several miles across, a solid core resisting solar heat, surviving perihelion without typical cometary degradation. For comparison, Halley's Comet, at similar distances from the Sun, sheds massive plumes of gas and dust. And yet, this interstellar visitor remained crisp, sharp-edged, and minimally altered. Thermal models suggest it should have lost material, yet radar and infrared readings detected no significant outgassing or erosion. Dr. Lang summed it up bluntly. "I've never seen anything this dense, this stable, this precise. Nature doesn't usually hand you perfection like this." Theories and hypotheses, from natural to speculative, scientists began mapping possibilities, each one more extraordinary than the last. Natural interstellar fragment, a fragment of a distant star system, unusually dense and non-volatile. Could be metallic, could be a remnant of planetary formation, but it breaks all known comet and asteroid physics. Technological relic, a passive probe, abandoned or inactive, perhaps sent by an extraterrestrial civilization eons ago. Reflective surfaces could explain sun-facing glints. Tumbling or spinning could create the observed light oscillations. Beacon or message. Some speculated a more active purpose. A signaling device, transmitting energy patterns via reflected sunlight or narrow spectrum emissions. The pattern of flashes, though subtle, could encode information. Unknown physics. Perhaps our models of interstellar object dynamics are incomplete. Radiation pressure, magnetic fields, or exotic materials could explain part of its behavior, though none fully accounts for its observed precision, brightness, and durability. Each idea was evaluated rigorously. Peer-reviewed papers appeared within weeks, cautiously suggesting that the data defied conventional cometary physics, but none leapt to wild conclusions. Science demands restraint, but curiosity whispered louder than caution. A global observation campaign, observatories worldwide, joined the effort. Chil's Cerro Paranal Observatory, high-resolution optical imaging to track brightness oscillations. Hawaii's Mauna Kea telescopes, spectrometry to detect molecular outgassing, found none. Arecibo, like radar arrays, attempted to measure radar reflections, revealing a dense, possibly metallic core. Amateur astronomers across Europe and Asia reported flickering light patterns, confirming high-frequency albedo variability. Night after night, scientists stared at screens, tracing 3IATLAS path. Each new dataset deepened the mystery, nothing fit neatly. The light curve puzzle. Perhaps the most compelling evidence came from light curve analysis. Normally, a comet's brightness varies smoothly as its surface sublimates, or an asteroid's brightness oscillates predictably as it rotates. 3IATLAS was different. Irregular, brief spikes of light, inconsistent with rotation alone. Dr. Maria Chen, analyzing the curve at the European Southern Observatory, explained, "We simulated every known rotation and reflection pattern. None reproduce the observed intensity spikes. It's almost as if the object is signaling, or at least designed in a way that's unfamiliar to us." It's an uncomfortable place for any scientist. When the simplest, most boring explanations fail, and the only remaining options are either extraordinary natural phenomena or hints of something engineered. From observation to speculation, testing predictions, scientists immediately began testing hypotheses. If it's a metallic relic, radar and infrared should show consistent reflectivity across passes. If it's a beacon, the light flashes should carry a detectable pattern or modulation. If it's a natural anomaly, then chemical analysis should eventually detect unusual isotopes or elemental compositions. Already, predictions were being made. Already, telescopes and satellites were lining up future passes. And already, the world was watching. 3IATLAS, the interstellar highway, and the mystery of its path. By now, the world's orbital mechanics, experts were leaning forward in their chairs. The data streaming from ESA, NASA, And independent observatories had one stubborn, undeniable fact: 3IATLAS' path through the solar system was extraordinary. Most interstellar objects, like Oumuamua in 2017, plunge into our system at steep angles, a chaotic visitor from some distant star. They swing past the sun, barely interacting with planets, and continue outward, leaving astronomers scrambling for observations. But 3IATLAS moved with calculated precision, almost like it had been designed to maximize interaction with the gravitational wells of our system. Its first significant deviation came near Mars' orbital radius. The object didn't simply drift by, it grazed the orbital plane, adjusting slightly under Mars' gravity. Then came Jupiter, the solar system's giant gatekeeper. The object's trajectory bent just enough to change its exit vector, reminiscent of a spacecraft performing a gravity assist, a technique carefully planned by mission engineers. Statistical simulations confirmed the anomaly. Out of tens of thousands of hypothetical interstellar objects approaching the solar system, the odds of a random object threading both Mars and Jupiter's spheres of influence in just the observed manner were vanishingly small. Scientists called it the cosmic coincidence problem. Dr. Kavita Rao sighed during a virtual press briefing. It's not impossible for a natural object to behave like this, but it's improbable enough to make you stop and think, what if we're missing something? Comparing interstellar visitors, Oumuamua and Borisov, the comparison was inevitable. Oumuamua's 2017, oddly elongated, tumbling, slight non-gravitational acceleration, minimal outgassing, suggested either a peculiar natural fragment or, controversially, a thin, reflective object. Borisov's 2019 classic Comet behavior, bright tail, heavy outgassing, icy composition. Clearly natural. 3IATLAS fell somewhere in between, but closer to Oumuamua in its anomalies. A solid core, minimal outgassing, unusual light behavior, and trajectory features that defy expectations for a random interstellar fragment. This isn't just DA'd view, Dr. Lang explained. We've now seen two outliers and one classic. The pattern hints that the universe may be sending us objects that don't conform to our expectations, objects that challenge our definitions of comet, asteroid, or probe. Light curves, albedo flashes, and the art of detection, one of the most puzzling aspects, remained the intermittent light spikes observed across multiple telescopes. These weren't constant. They weren't periodic in a simple rotational sense. Instead, they appeared as brief, irregular glints, sometimes lasting a fraction of a second, sometimes stretching across minutes. Dr. Maria Chen at ESO ran simulations for weeks, comparing models' rotational reflection. Couldn't reproduce intensity. Surface irregularities. Partially accounted for some flashes, but not the most extreme spikes. Artificial modulation. Could mimic the signal, but untestable without additional passes. Despite months of analysis, the flashes remained a tantalizing mystery. Each one suggested a structure or surface property unlike any typical comet or asteroid. Thermal models. Surviving the sun heat should destroy anomalies, but 3IATLAS survived perihelion with minimal change. Thermal emission models predicted sublimation rates orders of magnitude higher than what observations indicated. Even reflective surfaces should scatter heat unevenly, yet infrared data showed remarkable thermal stability. Dr. Vargas noted, "This object is surviving in a way we didn't think possible. Its composition or structure is unlike anything we've cataloged. Dense, stable, resistant. It's a cosmic puzzle box." Some hypothesized metallic content, others suggested exotic carbon-based structures, but none fully explained the combination of light reflection, thermal stability, and trajectory precision. Global coordination telescopes, satellites, and citizen scientists, the campaign to track 3IATLAS became a planetary effort, Cerro-Paranal, Chela-High. Resolution imaging to detect brightness oscillations. Mauna Kea's Hawaii spectrometry to confirm composition, looking for telltale signs of ice, rock, or metals. Radio telescopes, Australia and Spain, scanning for radio emissions. None detected yet. Amateur astronomers worldwide reporting brightness fluctuations, confirming glint patterns. The scale of collaboration was unprecedented. Night after night, data poured in, each observatory reporting variations, each measurement analyzed for anomalies. Yet, no consensus emerged beyond the undeniable fact 3IATLAS refused to fit conventional models. Hypotheses on the table. By mid-observation, the scientific community had outlined three main hypotheses: natural but anomalous interstellar fragment, composition highly metallic or carbonaceous behavior, stable low outgassing, unusual albedo technological relic Ehlers passive probe, reflective surfaces explain sun-facing glint, light curve irregularities could result from tumbling gravity assist, like trajectory hints at deliberate path design beacon or signal device. Light spikes might encode information, could be powered by internal energy. Light pressure, or exotic means, suggests intelligence, but remains speculative even as speculation mounted. Scientists stressed caution. Extraordinary hypotheses require extraordinary evidence, and at this point, none of the proposed engineered scenarios had been confirmed. The role of probability and statistical strangeness. Mathematicians began crunching the odds. The likelihood of a natural object entering the ecliptic and undergoing multiple gravity assist-like interactions. Extremely low. Probability of observing consistent albedo flashes in multiple independent datasets. Extremely low. Some argued these were just rare events, the cosmic lottery favoring our observation window. Others whispered about patterns too improbable to ignore. Dr. Rao leaned back in her chair, staring at a simulation of the solar system and 3IATLAS path. We may be seeing a pattern in randomness, or we may be seeing something engineered. At this stage, both remain plausible, preparing for future observations. As 3IATLAS exited the inner solar system, planning shifted from observation to anticipation. Teams calculated predicted future passes, potential solar reflection opportunities, and possible intercept missions. Some speculative discussions even broached sending a probe to catch up with 3IATLAS in the outer solar system. A Herculean challenge, but not impossible in theory. Meanwhile, scientists planned multi-wavelength follow-ups, optical, infrared, ultraviolet, refined light curve analysis to detect hidden patterns, radar scans to detect structural anomalies. The world waited. The object was leaving, but the questions it posed remained. 3IATLAS dancing with the planets. By mid-November, 3IATLAS had reached perihelion, skimming closer to the Sun than Mercury's orbit. The orbital mechanics team held their breath. Telescopes, satellites, and probes focused on this silent interstellar visitor, ready to catch every photon, every subtle reflection. The images revealed a sharp, needle-like core, perfectly illuminated by the sun. Unlike typical comets, there was no diffuse halo, no cascading tail. Minimal sublimation, almost like the object had learned to survive the heat. Dr. Helena Vargas described the scene with awe. "I've tracked comets for 20 years. I've never seen one act like this. It's pristine, impervious. It's almost as if the universe is testing our understanding of physics." The Mars flyby. Precision in silence. As 3IATLAS approached Mars' orbital plane, calculations showed it would pass within a few million kilometers. Close enough for subtle gravitational influence, far enough to avoid collision. Observations revealed nothing overt, no jets, no ejection of material, no sudden brightening. Yet, the trajectory bent exactly as a gravity assist would predict, increasing heliocentric speed and adjusting its exit vector with uncanny accuracy. "It's like watching a cosmic billiard ball," Dr. Rao said. "But there's no cue, no visible mechanism pushing it. And yet, it moves with the precision of a spacecraft designed by engineers." Jupiter's influence. A cosmic slingshot, the next major bend came near Jupiter. Here, the gas giant's immense gravity created a slingshot effect, altering the object's path toward the outer solar system. Observers noted minute accelerations, detectable only through precise orbital measurements. Standard physics suggests such acceleration would require outgassing, radiation pressure, or collisions with micro-meteoroids. Yet none of these explained the observed changes. Outgassing was negligible, collisions too sparse, radiation pressure insufficient. Dr. Michael Lang, analyzing radar reflections, said quietly, "If this is natural, it's unlike anything we've catalogued. If it's engineered, well, It's behaving exactly like a designed trajectory shield. Light flashes natural irregularities or signals. During the perihelion passage, the object's intermittent light spikes intensified. Ground-based telescopes reported flashes lasting fractions of a second, followed by dim intervals, then sudden brightness again. Scientists proposed several explanations. Surface irregularities reflecting sunlight, as it spins variable material composition, causing local heating and reflection. Deliberate modulation. The pattern matched none of the known natural cycles, DACTA. Maria Chen's simulation suggested that, if the object were a tumbling metallic probe, the observed flashes could be perfectly explained by specular reflection at specific angles. Yet, without additional data, the hypothesis remained unconfirmed. Thermal behavior, defying expectations. Perihelion also brought thermal analysis. Using infrared data from multiple satellites, scientists confirmed 3IATLAS remained thermally stable, radiating heat smoothly, without creating the expected sublimation plume of a comet. Heat should have ripped it apart, said Dr. Vargas. It didn't. It's as if the object has a composition designed to survive extreme solar radiation. Dense, reflective, possibly metallic, or some exotic material we haven't encountered. The combination of structural integrity, trajectory precision, and unusual light behavior left researchers in a state of cautious awe. Hypotheses under the microscope. By now, 3 competing hypotheses were central to discussions. 1. Natural fragment dense, highly reflective interstellar rock or metallic fragment. Could survive perihelion without outgassing, explains some anomalies, but not the precise gravity, assist, like trajectory or repeated light flashes. 2. Passive technological probe tumbling. Reflective surfaces account for intermittent glints. Gravity, assist, like trajectory, could be intentional. Durable construction explains survival under solar heat. 3. Beacon or active device, light flashes could be encoded messages. Perihelion passage provides optimal solar illumination. Implies intelligence. Though still speculative, each hypothesis made testable predictions. Observatories focused on confirming or rejecting each one, planning for potential follow-up missions. Visualizing the journey cinematic perspective. Imagine, if you will, a camera slowly tracking 3IATLAS from Earth, a silvery needle, glinting under solar illumination, glints and flashes rhythmically flickering along its surface, Mars and Jupiter in the background, tiny spheres affecting its path, solar glare streaming across the frame, yet the object remains unscathed. Every frame tells a story of physics defied, of precision unexplained, of a silent visitor that passes through human curiosity as much as through space itself. Global scientific response. The world's astronomical community responded with unprecedented coordination. Cerro Paranal tracked subtle brightness variations, Mauna Kea and Palomar, spectral analysis to detect material composition. Radio telescopes worldwide, scanning for anomalous signals, amateur astronomers documenting albedo flashes, providing independent verification. Observations confirmed that the anomalies were real, not artifacts. Every dataset reinforced the conclusion. 3IATLAS was behaving unlike any known natural object, preparing for the future interception or observation. With the object moving beyond the inner solar system, scientists began asking bold questions. Could humanity catch up with a probe to examine it directly? Are there detectable patterns in its light curve that could reveal structure or function? Might 3IATLAS carry clues about interstellar processes or even intelligence? While a physical intercept was technologically challenging, observational campaigns could continue for years, especially during optimal reflection windows when the sun illuminated the object for Earth-based detection. The natural vs. engineered question, and so we reach the central question: natural or engineered? Every natural hypothesis struggles to explain trajectory, structural integrity, and light behavior simultaneously. Every engineered hypothesis remains speculative, lacking direct evidence but matching observed anomalies in ways natural models cannot. Dr. Rao summarized, "We are at a crossroads between the mundane and the extraordinary. Either we are witnessing a new class of interstellar object, previously unknown, or we are seeing a visitor designed with capabilities that exceed our imagination. Either way, it forces us to rethink what's possible in the cosmos. The 3IATLAS, the final act natural or engineered? As 3ATLAS recedes toward the outer solar system, the debate reaches its zenith. Telescopes continue to track it, satellites continue to record, and minds around the world spin with possibilities. We've seen a sharp, luminous core, survived perihelion, threaded planetary flybys with uncanny precision, and flashed sunlight in patterns that defy simple physics. Every observation challenges our expectations. Every dataset hints at a puzzle larger than any single anomaly. And yet, we cannot definitively call it artificial, nor can we comfortably claim it is purely natural. The truth, as always, lies somewhere in the tension between observation and imagination. Scenario 1. A natural interstellar fragment. Let's begin with the simplest explanation: 3IATLAS is natural. Perhaps it is a dense, metallic fragment, born from a planetesimal collision in another star system. Perhaps its trajectory along the ecliptic is a statistical fluke, an improbable but not impossible path. Perhaps its light flashes are caused by surface irregularities, reflecting sunlight as it tumbles, exaggerated by observational angles. If true, 3IATLAS represents a new class of interstellar object, one that survives stellar heating, avoids outgassing, and remains structurally pristine across light years of space. It would change everything, Dr. Varga said. Our models of comet and asteroid formation, our understanding of interstellar debris, would all need revision. It's not alien, but it's extraordinary. Even in this natural scenario, the object defies expectations, reminding us that the universe still has secrets to reveal. Scenario 2. The technological relic now. Consider a bolder hypothesis. 3IATLAS is a passive probe, a relic of intelligence not of our making. Tumbling, reflective surfaces explain the light flashes. Structural integrity explains survival through perihelion. Gravity assist like trajectory hints at intentional planning. If so, the object is ancient, drifting silently across interstellar space, potentially millions of years old, a message in metal and light. Dr. Lang pondered aloud. If it's a probe, it's one designed for patience, observation, endurance. It doesn't rush, it doesn't signal, it just exists. And by doing so, it asks us to watch, to learn, to consider that intelligence may travel the stars in ways we cannot yet comprehend. This scenario raises profound questions. What civilization created it? How old is it? What was its purpose? We may never know, but its silent journey carries the weight of possibility. Scenario 3. A beacon. Finally, the most speculative 3IATLAS is a beacon, a message encoded in light and motion. Its intermittent flashes may carry information, modulations in intensity or timing, meant to be observed by an intelligent species. Its trajectory along the ecliptic maximizes visibility to planets orbiting the Sun, perhaps intentionally targeting intelligent observers. Survival through perihelion ensures the message isn't destroyed by solar radiation. This idea borders on science fiction, but the universe has repeatedly shown us that our imagination often underestimates reality. Even if it is a beacon, we may lack the tools or understanding to decode its signal. Dr. Rao reflected. If it's a message, it's patient. It doesn't demand response, it simply exists, waiting for a species capable of noticing. The philosophical weight. Beyond the science lies the deeper question. What does 3IATLAS mean for humanity? If natural, it reminds us that the cosmos is more diverse than our models predict. If engineered, it hints at intelligence beyond Earth, challenging our assumptions about life and communication. Regardless, it demonstrates our growing ability to observe, track, and analyze interstellar phenomena, a skill humanity has only recently developed. This object forces us to confront our place in the universe. For centuries, we believed the stars were distant, silent, unreachable. Today, one has passed through our solar system, leaving clues, patterns, and questions. It is a humbling reminder the universe is not merely to be studied. It is to be experienced, to be pondered, to ignite wonder. The cinematic vision. Imagine a camera sweeping through space. 3IATLAS, glinting in the sunlight, threads the planetary corridors of the inner solar system. Mars looms in the distance, a silent witness to its passage. Jupiter's gravity bends its path subtly, a giant gatekeeper granting passage. Flashes of reflected light dance across its surface, patterns too precise for coincidence, too fleeting for certainty. The narration slows, voice trembling with awe. It came from the stars. It saw our planets, and it continues on its journey, silent, mysterious, untouchable. We may never know its origin. We may never know its purpose, but we have seen it, and that is enough to change everything. A future observations and humanity's response. Even as 3IATLAS leaves the inner solar system, the scientific community plans future encounters, long-range optical and infrared monitoring, refined light curve analysis to detect hidden periodicity or patterns, radar imaging from distant arrays to estimate density, shape, and composition. Some visionaries have even proposed future interception missions. Although catching an object moving at interstellar velocity is an engineering challenge beyond today's technology, yet, the very fact we can consider it reflects humanity's rapid growth as a cosmic observer. Dr. Chen reflected, "We are the first species to witness interstellar objects up close. Every observation is a lesson, every anomaly, a question. 3IATLAS may leave us without answers, but it has already expanded our understanding of what's possible." The silent journey continues. As the solar system fades behind it, 3IATLAS becomes a wandering messenger, a traveler on an eternal path. Its light will eventually fade from Earth-based observatories, yet its legacy remains, challenging our understanding of cometary and asteroid physics, suggesting the possibility of technological artifacts from other civilizations, inviting humanity to look beyond, to wonder, and to question. In the quiet of space, it glides silently, a reminder that the universe is vast, unpredictable, and full of mysteries. A closing reflection, perhaps the true message of 3IATLAS is not in its flashes, its trajectory, or its composition. Perhaps the message is in the act of observation itself, that humanity can track, analyze, and marvel at objects from beyond our star, that we can confront anomalies with both skepticism and imagination, that in watching the cosmos, we watch ourselves, curious, daring, capable of wonder. It is an invitation to explore, to question, to look upward, knowing that the universe is alive with possibilities. Dr. Rao's final words resonate as the camera pans away. Whether natural, relic, or beacon, 3IATLAS is a reminder the stars are not silent. And sometimes, they send a visitor just to make us listen. Epilogue: a universe of visitors, 3IATLAS will continue its journey, disappearing into the darkness of interstellar space. Yet it leaves behind a world changed. Astronomers will refine their models of interstellar objects. CTI programs will reassess what constitutes a potential signal. Humanity will carry a renewed sense of cosmic humility and curiosity. The universe has once again whispered to us through an object no larger than a city, and in its silence, it speaks louder than any words. The cosmos is stranger, more beautiful, and more mysterious than we have ever imagined, and we are just beginning to understand. 3IATLAS, a data odyssey. To understand 3IATLAS is to understand the patience, precision, and ingenuity of the global astronomical community. Night after night, telescopes captured light curves, spectroscopy, and radar data, each dataset adding layers to the puzzle. Optical observations. Multiple observatories tracked brightness fluctuations across wavelengths. The amplitude of these oscillations suggested rotation or tumbling, but the irregularity defied standard tumbling models. Peaks occurred at inconsistent intervals, hinting at complex surface geometry or reflection patterns. High-resolution imaging revealed minute surface features, irregular ridges and possible facets, yet no outgassing jets. Spectroscopy spectrometers aimed at capturing molecular signatures, CO found no detectable sublimation, confirming earlier ExoMars results. Infrared spectra suggested a metallic or silicate-rich composition, but with anomalies inconsistent with typical asteroids or known interstellar fragments. Ultraviolet observations ruled out significant volatile emissions, further confirming its anomalous nature. Dr. Maria Chen explained, Each wavelength tells a story. The visible light gives us shape and reflectivity. Infrared tells us composition and thermal behavior. UV shows us what it doesn't have. When you combine them, the object simply refuses to behave naturally. Extended light curve analysis over weeks. Light curve monitoring revealed subtle periodicities hidden within irregular flashes. Analysts used Fourier transforms, wavelet analysis, and machine learning algorithms to tease out patterns. Some patterns suggested a rotational period of several hours, but intermittent spikes broke the periodicity. Other analyses indicated a secondary modulation, possibly caused by surface facets reflecting sunlight differently as the object tumbled. Dr. Lang noted, "It's like listening to music with half the notes missing. You can detect the rhythm, but the melody is strange, unpredictable, and unlike anything in our catalog." These light curve studies would become the foundation for speculation about artificial origin, as some patterns resembled engineered reflective sequences, though evidence remained circumstantial. Comparative analysis, Oumuamua, Borisov, and 3IATLAS, the object's anomalies became clearer when compared with previous interstellar visitors. Oumuamua C 2017 elongated, tumbling, slight acceleration inconsistent with visible outgassing, proposed as a thin, reflective object or light sail, like natural fragment. Borisov's 2019 say, classic comet with heavy outgassing, tail formation, icy composition, clearly natural. 3IATLAS 2025 of dense, sharp-edged, minimal outgassing, intermittent flashes, trajectory resembling planned gravity assists. Dr. Rao summarized, Borisov was mundane, Oumuamua was odd, 3IATLAS is outright mysterious. It challenges everything we assumed about interstellar visitors. The pattern was clear: interstellar objects are more diverse than previously believed, and our observational tools were only now catching the extremes. Trajectory modeling, simulations and anomalies. Scientists ran thousands of N-body simulations to understand 3IATLAS path. Using precise measurements of position, velocity, and acceleration, they examined purely gravitational models, sun planets, radiation pressure effects, minimal outgassing scenarios. The results, even under all plausible natural models, the object's gravity, assist-like deviations, and subtle acceleration could not be fully explained. Dr. Lang commented, "It's almost as if the object is nudged by a hand we cannot see." Of course, that's not a conclusion. But the numbers are uncomfortable. You stare at them long enough, and you have to acknowledge the anomaly. Cinematic visualization, perihelion and planetary flybies. Imagine the journey from a cinematic lens. A distant Earth-based telescope frames the object approaching the inner solar system, the sun flaring behind it. Mars appears as a tiny orb, the object bending subtly, passing through the ecliptic with precision. Jupiter looms as a massive gravitational anchor, sending 3IATLAS on its outward trajectory. Glints of light flicker from the object's surface, brief and rhythmic, like a cosmic Morse code. This visualization isn't fiction. It mirrors real orbital calculations and observational data. The cinematic perspective allows audiences to feel the tension, the scale, and the strangeness of a visitor from beyond. Debating natural vs. engineered origins. With the data in hand, three primary hypotheses dominated the discussion. 1. Natural fragment, dense metallic or carbonaceous composition. Gravity, assist-like trajectory as a statistical anomaly. Light flashes caused by irregular surfaces or tumbling challenges. Improbable trajectory alignment. Persistent flashes inconsistent with simple rotation. 2. Passive probe, technological relic. Tumbling reflective surfaces explain intermittent flashes. Survival of perihelion explained by engineered durability. Trajectory suggests intentional design. Subtle but effective challenges. No detected radio or energy emissions. Purely speculative. 3. Beacon or active device. Intermittent flashes could encode a signal path through ecliptic, maximizes visibility to planets. Could be powered by internal energy or reflected sunlight. Challenges. No definitive message detected. Hypothesis stretches current understanding. The philosophical dimension, beyond science. 3IATLAS forces reflection. What does it mean if intelligence exists beyond Earth? Could the universe be sending messages? we are barely equipped to understand. Does the act of observation itself constitute a response, a recognition of the cosmos' vastness? Dr. Rao spoke quietly during a late-night briefing. Whether natural or engineered, the universe has introduced something utterly unfamiliar. It forces humility, it forces curiosity, and it reminds us that our perspective is limited. Preparing for future encounters, even as the object recedes, humanity plans ahead. Multi-wavelength observation campaigns continue. Targeting potential reflection angles, radar studies aim to detect shape and density with higher precision. Long-term trajectory predictions allow astronomers to track 3IATLAS for years. Observing for unexpected behavior, speculative missions have been proposed: intercept probes, remote sensing arrays, even sample return concepts. Ambitious, yes, but technically conceivable within the next few decades. Extended scientist dialogue. To bring it cinematic, Dr. Chen's. Every night I check the light curve, and every night it surprises me. Nature shouldn't do this, but perhaps it does. Dr. Lang. We've always imagined interstellar objects as rocks and ice. But what if some of them carry design, purpose, or history beyond our comprehension? Dr. Vargas. If it's engineered, it's patient. It waits. We observe. And through observation, we begin to understand the cosmos in new ways. These conversations humanize the narrative, showing scientists wrestling with wonder, skepticism, and excitement. Cinematic final reflections on the universe. Imagine the final frames: 3IATLAS receding toward the stars, a glinting sentinel of the unknown, Earth shrinking in the background, telescope still pointing, cameras still recording a narrator in tones. It came from the stars, traveled millions of miles, and left us with questions larger than answers. We may never touch it, never decode it, never know its origin. But we have seen it, and that is enough to change everything. The story closes with a sense of awe and mystery. Science has gained data, observations, and models, but the universe has kept its deepest secret intact. The night skies were alive with anticipation. Across continents, from the Chilean Atacama Desert to the icy peaks of Mauna Kea, telescopes and observatories trained on a single target: 3IATLAS, a visitor from another star system, threading the solar system with silent precision. It glimmered against the cosmic backdrop, a needle-like silhouette of light, defying the expectations of astronomers and physicists alike. Its core was sharp, solid, resilient. Unlike every comet humanity had studied, it displayed almost no tail, no outgassing, no chaotic debris cloud, just clarity and consistency. Dr. Michael Lang, staring at the latest photometric data, murmured, "I've tracked thousands of asteroids, dozens of comets, and even Oumuamua. But nothing in my experience behaves like this. It's precisely too precise." The term, cosmic coincidence, began to circulate in scientific circles, but even that phrase failed to capture the strangeness of what astronomers were observing. Expanded observational campaign. The global response to 3IATLAS was unprecedented optical imaging. Continuous high-resolution imaging revealed the object's subtle rotation and intermittent reflective flashes, glinting like sunlight off a distant metallic surface. Observers noted irregular intervals between flashes, suggesting a complex surface geometry, or perhaps an engineered reflective pattern. Spectroscopy. Across ultraviolet, visible, and infrared wavelengths, scientists detected no significant volatile emissions. Unlike typical comets, there were no water vapor signatures, no carbon-based sublimation, and no dust plumes. Infrared data suggested a dense, possibly metallic or silicate, rich composition, consistent with a thermally stable interstellar fragment. Radar observations. Ground-based radar arrays measured a compact, elongated object, consistent with the sharp core observed optically. Reflections were uniform, showing surface smoothness interspersed with angular features, potentially explaining intermittent glints. Citizen science contributions. Amateur astronomers confirmed fleeting flashes independently, demonstrating the global nature of the effort and adding credibility to previously anomalous observations. Dr. Maria Chen described the data to her colleagues. Each dataset is like a piece of a puzzle, and every piece challenges our assumptions. Nothing about this object conforms to what we've catalogued before. Trajectory analysis. The cosmic highway, perhaps the most astonishing aspect of 3IATLAS, was its trajectory. Unlike previous interstellar visitors, Mars flyby, 3IATLAS approached Mars' orbital plane at a precise angle, bending slightly under the planet's gravity, increasing its heliocentric speed. The effect was subtle, yet measurable. Jupiter's slingshot passing near the gas giant, the object's path curved with near-perfect efficiency, a textbook gravity assist maneuver, but achieved without engines, without detectable propulsion. Ecliptic alignment. Unlike Oumuamua's steep, almost random entry angle, 3IATLAS, path remained closely aligned with the ecliptic plane, maximizing interactions with planetary gravity wells and suggesting either an extraordinary natural coincidence or deliberate design. Dr. Kavita Rao reflected, "If this is natural, it's the luckiest fragment in interstellar space. If it's engineered, then the creators understood orbital mechanics far beyond anything we can currently replicate." Light curves. Patterns in the glints. The object's intermittent flashes were both fascinating and confounding. Irregular flashes defied conventional tumbling models. Fourier analysis and wavelet transforms revealed hidden periodicities, suggesting rotation periods of several hours. Some spikes seemed too precise, too rhythmic, to be entirely natural. Dr. Lang summarized the dilemma. It's as if the object is speaking in a language we don't yet understand. Not sound, not radio waves, but light. Tiny pulses from the depths of space. Speculation began to extend beyond conventional astrophysics. Could these flashes represent engineered signals? Or were they the result of unique material properties, previously unknown in natural interstellar objects? Thermal stability and structural integrity. Perihelion passage should have been destructive. Solar heating at close approach would normally produce dramatic outgassing, tail formation, and erosion. 3IATLAS exhibited none of these. Infrared measurements confirmed minimal heat absorption and uniform radiation. Radar data indicated structural integrity, suggesting a dense, possibly metallic or exotic composition. Comparative models of comets and asteroids under similar solar exposure predicted catastrophic fragmentation. Yet this object remained intact. Dr. Helena Vargas remarked, "It survives because it must. Whatever it's made of, or however it was formed, it defies the physics we know, or pushes it to extremes. Natural vs. engineered." The debate 3 hypotheses dominated scientific discussion. 1. Natural fragment, a dense interstellar object, possibly metallic or carbonaceous gravity. Assist, like trajectory, is a statistical anomaly. Light flashes caused by irregular surfaces or tumbling challenges. The probability of such a path and stable thermal behavior occurring naturally is astronomically low. 2. Passive probe, Ulria's relic, reflective surfaces, explain flashes, durable structure, explain survival through perihelion. Trajectory could be intentional challenges. No detected energy emissions or communications. Still purely speculative. 3. Beacon flashes may encode information. Ecliptic trajectory maximizes observability. Could be powered by internal energy or sunlight challenges. No message has been decoded, making this the most speculative scenario, but the most intriguing. Dr. Rao mused, "Even if it's a relic or a beacon, it doesn't need to communicate in a way we understand. Its existence alone is a message the universe is vast, and intelligence may take forms we cannot yet comprehend." Cinematic visualization. Imagine a final cinematic sequence. Close up 3IATLAS, a needle of light, spins gently, catching sunlight and casting reflective glints across space. Mars in the background. The object curves subtly, bending under gravity. No debris, no chaos, just precision. Jupiter looms. Its immense gravity bends the path further, sending the object back into the void. Earth fades into the distance. Telescopes continue to track, cameras recording, data streaming. The narrator intones, "It came from the stars, passed silently through our solar system, and continues its eternal journey. We may never touch it. We may never understand its origin. But we have seen it, and that is enough to change everything." That extended scientist dialogue. The narrative is enriched by the human element. Dr. Cheney Every night, I watch the light curve. It surprises me. It teases me. Nature shouldn't do this, but perhaps it does. Dr. Lang. We've always imagined interstellar objects as rocks or ice. But this might be something else entirely. Something that tests the limits of physics, or hints at intelligence. Dr. Vargas. If it is engineered, it is patient. Millions of years old, drifting silently, waiting for observers like us. And through observation, but we begin to understand the universe in ways we never imagined. These conversations emphasize both the scientific rigor and the emotional awe surrounding the encounter. Philosophical implications beyond science. 3IATLAS forces humanity to confront deeper questions. What does it mean if intelligence exists beyond Earth? Could the universe be sending visitors as silent messages, meant only to be observed? How does humanity respond to an anomaly that challenges everything we know? Dr. Rao's reflection captures the essence. Whether natural or engineered, 3IATLAS forces humility, curiosity, and imagination. It reminds us that our perspective is limited, but our capacity for wonder is infinite. Future prospects. Even as 3IATLAS fades from view, plans are already underway. Long-range observation campaigns track light curve, thermal, and spectral data. Radar studies aim to refine density and shape estimates. Speculative mission concepts. Consider intercept or flyby missions decades into the future. The object may leave the solar system, but its legacy endures. It has expanded humanity's understanding of interstellar objects, SETI, and cosmic possibility. Closing reflections. Perhaps the true significance of 3IATLAS is not in its physical composition or trajectory, but in the act of observation itself. Humanity is watching, analyzing, and marveling. We are learning to interpret anomalies and challenge assumptions. We are expanding the boundaries of curiosity, imagination, and understanding. It is a reminder that the universe is alive with mystery, and that every anomaly carries lessons far beyond immediate comprehension. Dr. Lang's final words. It came from the stars, and in its silence, it speaks louder than any words we have ever known. Epilogue. A universe of visitors. As 3IATLAS drifts into interstellar space, Earth is left with a profound realization. Interstellar objects are diverse, surprising, and sometimes anomalous. The boundary between natural phenomena and intelligence may be far thinner than we imagined. Observation, patience, and curiosity remain our greatest tools in understanding the cosmos. The universe has delivered a visitor no larger than a city, yet it leaves humanity changed, curious, humble, and aware that the stars are not silent. The cosmos whispers through 3IATLAS, stranger, stranger, and ever more wondrous than we can imagine.